Hello engineers, today we'll discuss an important topic that is on practical cable sizing calculation. How to select the cable required for the specific work. Before going to the cable sizing, whether for ST cable or LT cable, we have to follow the methods sequentially. First, we have to calculate the load current for three-phase system. If the system is three-phase, then we calculate the current that is equal to power divided by root 3 V power factor into efficiency, where P is the load in kilowatt or megawatt, V is the line voltage in voltage or kV, power factor and efficiency. And then after that, we'll go for separately for LT cable and as well as ST cable. First, for LT cable, you see, first current carrying capacity. You have to know what is the current carrying capacity. In the step 1, we have already known the load current. As per that, we have to select a load current, select the cable from the data sheet. That means our load current, you have to select the current, rated current of the cable should be more than that of the load current. While selecting the size of the current rating, we have to refer the standard documents, that is IS 3961 and IEC 60502. Then next comes the directing factor. Directing factors, there are three types. One is due to ambient temperature, another due to the grouping of cables, and third one is due to the soil resistivity for the buried cable. So the value of the directing factors is separate for separate directing factors, but we have to find out the effective directing factor by multiplying the individual directing factors. Here our K effective is equal to K1 into K2 into K3. So first, for LT cable, we see the current capacity, then application of directing factor, and after that we found the effective current, what is I effective, that is equal to K effective into I. K effective into load current. Then we come to checking a voltage drop. In selection of the LT cable, we have to avoid this point. this checking point, that is the voltage drop. Here voltage, to calculate the voltage drop, we have to apply this formula, that is your root 3 I r cos phi plus x sin phi, means resistance and reactance of the cable having length L, divided by the system voltage multiplied by 100. This is the percentage voltage drop, and this should be checked that if our load is light, then it must be less than or equal to 3%, and if it is power load, it is less than 5%. The next step is your short circuit withstand. So to withstand the short circuit current, accordingly we have to calculate the size of the conductor, where A is equal to ISC, short circuit current, into root over T, or duration, divided by K. K is a material constant. For copper, it is 150. Finally, the cable is chosen from the standard size of the conductors in mm square. Let us practically see some example, taking a specific example practically for LT cable. Suppose given load is 500 kilowatt and voltage is 415 volt, and suppose say power factor is 0.9. In that case, first we have to find out what is the load current. Here I is equal to 500 into 10 to the 3 divided by root 3 by 415 into 0.9, that is approximately 773 ampere approximately. Step 2, the cable selection. From that means keeping this current into consideration, we have to select the suppose if we select one run of 400 square mm can carry only 600 ampere current, which is not sufficient. So that is why we have to select 2 runs of 400 square mm. This is sufficient to carry the above the load current. That means then the next one is your step 3, voltage drop is checked, applying the formula given above. You have to see that it must be less than 5% if it is power load. Then next step, short circuit checking, short circuit current checking. In turn, it must withstand the capacity of the cable to be verified with a fault current for 1 second. So these are the basic steps to select the LT cable. Now we'll discuss the cable sizing in case of ST cable. First we check for load current. For load current, we can apply the formula I is equal to S by root 3 into V, where S in the kVA or MVA. Then current is taken from the manufacturer's datasheet or IC standard. Secondly, the installation method should also be considered, whether it is go or install underground or buried, or it is on the tray, or the method of installation depends upon the method of installation. Then we have to take the account of soil resistivity. It is a buried cable. The next step is our short circuit rating. The ST cables are mainly selected on the basis of fault current. So it is most critical step for selecting the ST cable. In this case, we find out what is the fault level MVA, that is rated MVA into 100 divided by impedance in percentage Z. Then fault current is calculated, that is ISC, fault current is equal to a fault level MVA divided by root 3 into system voltage. Then to check here, your cross-sectional area must be greater than or equal to ISC into root T by K. You have to check this for short circuit rating. Then in case of voltage drop checking, it is not necessary because it is within limit due to the high voltage. Similarly, insulation level is chosen as per the voltage level. For example, the 11 kV, it is from 12 to 20 kV grade, 12 or 20 kV grade, and for 33 kV, it will 19 or 33 kV grade. Or in some cases, we may take in 36 kV grade. The practical, we have to take some practical example for cable sizing of the ST cable. For example, for a power system, it is given that the transformer MVA is 10 and a system voltage is 11 kV. We have to find out the load current. I is equal to 10 into 10 to the power 6 MVA divided root 3 into 11,000. This comes out to approximately 525 amperes. Then choose 240. For this, we have to choose 240 square mm cable or 300 square mm cable, SLP ST cable. Verify the short circuit rating of the cable with 25 kiloampere for 1 second. It also be to be verified. During the selection of cable size, we have to emphasize on few essential practical points. That is, we have to always prefer multiple runs instead of one huge cable. Suppose we have to require some cable that is total current is matching with one core cable. So for that we will prefer multiple runs to match the current. Multiple runs. We have to take multiple runs instead of one single cable, single huge cable. Then secondly, we should not neglect the future load expansion. So during the calculation, we have to take the load current 20 to 25% excess. 20 to 25% above the normal load current for future expansion. Always we will prefer aluminum than copper because for a cost point of view. For LT cable used in substations, we prefer 3.5 core or 4 core cable. For ST cable, we prefer single core 3 runs. So finally, discussing all these factors, finally we have to finalize the proper sizing without any defect or without any mistake. We should take into account the checklist as per given here. Before finalizing the cable, we have to check the load current, derating factors, voltage drop, short circuit capacity, installation method, and future expansion. These things to be taken into consideration.